Hey YouTube, welcome to the E-Lab, the channel for beginner and intermediate electronic hobbyists. And today we're going to be talking about the LDR, the Light Dependent Resistor, and how to use it in a circuit. Okay, let's get started. The LDR, which stands for Light Dependent Resistor, comes in all kinds of shapes and sizes. Here's a large one right here, and a smaller one between the two sizes. We're going to be using the smaller one in the circuit, but I wanted to show you with this larger one here how light acts through the LDR. So if we could see the meter, you can see that right now we're getting about 11 or 10.9, 10.6. And now it's bouncing around a little bit from the light. But now what happens, if I shine the light on the LDR, you'll see that it drops down to 0.5. I remove the light and it bounces back up to 11.2. So what's that doing? When the light shines on it, it's restricting the flow through the LDR. I turn off the light, the power flows back through. So that's how an LDR operates. Now we're going to put it in a circuit so you can see how to use it inside of a circuit. We'll need a breadboard and a 9-volt battery. And we'll need an LDR. We'll need 2 resistors and an LED. And as always, I'll put the circuit up in the corner so you can follow along a lot easier. Now, an LDR is not polarized. It does not have a plus or minus on it. It can go either direction, so it doesn't matter. So they're easy to use. So from the LDR, we're going to go from the positive and then the other leg into an available slot on the breadboard. Then we're going to go from the resistor to one end of the LDR here to another open slot on the breadboard. Then we're going to go from the anoid, the long leg of the LED, to the negative. Now, you can see that the blue light is on. The LED is on right now. And you're thinking, well, light's there, if that LED should go out. But no matter how hard I try putting my hand over it, I can make it dim a little bit, but light is still getting through there. It's very sensitive. So that's not going to work for the circuit. That wouldn't make a very good circuit if you try to hook it up, that whatever you're trying to control to go off or on is going to stay in its state because it's not turning off all the way. To remedy that, we're going to use another resistor that will go from in between the LDR and this resistor. We're going to go put one leg of another resistor right there, and then simply take the other side of the resistor and go to the negative. Now you see that LED went out. So what we did is we made the LDR work a little better when it sees light. So now when I take the flashlight, you'll see the LED go on. So anytime this sees bright light like the sun or anything like that, this LED would go on and stay on until it got dark or whatever light source you're using on it goes out. Now, the really cool thing about this circuit is I can do one simple thing to reverse it, to make the light always stay on and go out when it sees light. So it would be doing the opposite with one simple move. Simply take the LED out and turn it, so now that the cathode, the short leg, goes to one end of the resistor, and the anoid, the long leg of the LED, goes to the positive. And now you're going to see that this LED is on all the time until it sees light. So I take the flashlight and shine it on the LDR, and that LED goes out. Turn it off, LED goes back on. Shine on the LDR, LED goes out. So that's pretty cool, just with that one little move. We'll do it again. We'll take the LED out, turn it around, now putting the long leg to the resistor and the short leg back inside the negative, and it stays out. The LED will stay off until it sees light. Simply turn the light on the LDR and it sees it, and it's allowing the light to go back on. It's a pretty cool little circuit. Write down below in the comments, tell me how you would use an LDR or how you use it in your circuits, or any cool ideas you have with the LDR. As always, please go to our website. You'll get the schematics and other schematics that we have from the other videos for free. And as always, please, to help support this channel, buy one of my books on electronics, and that way we can keep bringing you cool electronic content. Thanks for watching the E-Lab.